Let's go back to the question and find out what is the correct answer. Let's go to the question number 2. What are 2 reasons why time synchronization between FortiGate and its managed FortiSwitch is critical in switch management? Choose 2. Let's move to the third question. Which statement about using MAC, IP and protocol-based VLANs on FortiSwitch is true? Question number 4. What conditions does a FortiSwitch need to have to successfully configure the options shown in the exhibit above? Question number 5. In which 2 ways can you assign a FortiSwitch port to a VDOM using multi-tenancy setup? Hello everyone, welcome to 591lab.com. Today we will be discussing Fortinet FortiSwitch 7.2 sample questions with the answers. Before moving to the questions, let me explain about 591lab.com, pronounced as 591 Lab. This is the top IT training and certification exam brand in China, Hong Kong, Taiwan and Singapore. Our mission at 591 Lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto and Fortinet exam tracks. Let's go through the content we will be discussing today. Number 1. DHCP snooping. Number 2. FortiSwitch time synchronization. Number 3. MAC, IP and protocol-based VLANs. Number 4. Split ports. Number 5. Multi-tenancy. Number 6. MAC address quarantine. Number 7. ACL. Okay, let's move on to the first question. Which 2 statements about DHCP snooping enabled on FortiSwitch VLAN are true? First, let's understand what DHCP is. DHCP stands for Dynamic Host Configuration Protocol. It is a network protocol that automates the process of assigning IP addresses and other network configuration information to devices on a network. The primary purpose of DHCP is to simplify the management of IP addresses within a network. DHCP client goes through a process which consists of 4 steps. Step 1. DHCP Discover. A DHCP client sends a broadcast packet to discover DHCP servers on the LAN segment. Step 2. DHCP Offer. The DHCP servers receives the DHCP Discover packet and respond with DHCP Offer packets, offering IP addressing information. Step 3. DHCP Request. If the client receives the DHCP offer packets from multiple DHCP servers, the first DHCP offer packet is accepted. The client responds by broadcasting a DHCP request packet requesting the network parameters from the server that responded first. Step 4. DHCP Acknowledgement. The DHCP server approves the lease with a DHCP acknowledgement packet. The packet includes the lease duration and the other configuration information. Now you understand what DHCP is. Now let's understand what is DHCP snooping. DHCP snooping is a security feature implemented in network switches to mitigate the risk of rogue DHCP servers on a network. A rogue DHCP server could potentially distribute incorrect or malicious IP configuration information to devices on the network, leading to connectivity issues or security vulnerabilities. DHCP snooping helps prevent such unauthorized DHCP servers from operating on a network. And also, DHCP snooping protects the DHCP service in your network from rogue DHCP servers and information leak. By inspecting DHCP traffic, can identify that there are two main categories of DHCP snooping. Category number 1, DHCP replies. This contains offer and acknowledgement packets, and it is accepted on FortiSwitch trusted ports only. Category number 2, DHCP requests. This contains discover and request packets. By default, FortiSwitch DHCP Snoop client RIC is set to forward untrust, which means that DHCP requests are forwarded to untrusted ports. Let's go through this example. Look at the diagram. You enable DHCP snooping on a VLAN and then you configure a port as trusted or untrusted. The example on this slide shows a switch with 3 endpoints connected. The port that connects the trusted DHCP server is configured as trusted, and the port that connects the rogue DHCP server as untrusted. The result is that FortiSwitch accepts DHCP replies from the trusted DHCP server only. DHCP replies sent by the rogue DHCP server are dropped by FortiSwitch. In addition, if DHCP Snoop client request is set to drop untrusted, FortiSwitch forwards requests sent by the DHCP client to the trusted DHCP server only. In the example shown on this diagram, this would result in the rogue DHCP server not receiving the DHCP request packet from the DHCP client. Let's understand what is DHCP option 82. DHCP option 82, also known as DHCP relay agent information. This can be used to protect the network against spoofing attacks on DHCP requests. When enabled, FortiSwitch adds option 82 to DHCP requests made by clients. By default, option 82 contains the following client-specific connection information. First one, circuit ID. Second, remote ID. Circuit ID contains the client port ID, the client VLAN ID, and DHCP mode. When DHCP snooping is enabled, the mode becomes DHCP-S. When DHCP relay is enabled, this becomes DHCP-R. Option number 2, remote ID. This contains the FortiSwitch MAC address. This is usually the MAC address of the internal interface. To enable DHCP option 82, you can only use CLI mode. Further information related DHCP and DHCP snooping can be studied more on FortiSwitch 7.2 study guide starting from page number 212. Let's go back to the question and find out what is the correct answer. Answer A. Settings related to DHCP option 82 are only configurable through CLI. As we learned, now you know that this answer is correct. Answer B. Switch controller DHCP snooping verify MAC verifies the destination MAC address to protect against DHCP exhaustion attacks. This answer is wrong. It verifies the source, not the destination MAC address. Answer C. Enabling DHCP snooping on a FortiSwitch VLAN ensures requests and replies are seen by DHCP servers. No, this answer is incorrect. Answer D. By default, all FortiSwitch ports are set to forward client DHCP requests to untrusted ports. This answer is correct. So the correct answers for this question are answer A and D. Let's go to the question number 2. What are two reasons why time synchronization between FortiGate and its managed FortiSwitch is critical in switch management? Choose 2. Time synchronization is the most important part in FortiSwitch management. If the time on FortiGate and FortiSwitch does not match, FortiSwitch can't complete DTLS handshake used in CAPWAP, which prevents the switch from connecting to FortiGate. Another point to have a working setup for time synchronization is because FortiSwitch does not retain its time after a reboot. When the FortiSwitch is rebooted, the time on the switch is reset to the default Unix epoch time. If you are connecting FortiSwitch to FortiGate, the first step to check time synchronization is by checking the NTP system configuration on FortiGate. You can check the NTP status on FortiGate by running command diagnose sys NTP status. The output should indicate that the time is synchronized, that NTP synchronization is enabled, and that server mode is enabled. The output should also indicate the selected NTP server by FortiGate to synchronize its time. Execute time command to display the current system time, as well as that the last time synchronized using NTP. Note that by default, NTP time synchronization happening every 60 minutes. Let's understand what is CAPWAP, since it is mentioned in this question. CAPWAP is control protocol that FortiGate uses to manage FortiGate switch devices. It does switch authentication, authorization, and health checks, also known as heartbeats, by establishing a datagram transport layer security DTLS tunnel between FortiGate and the switch. NTP used by FortiSwitch to synchronize its time with FortiGate. Time sync between FortiGate and FortiSwitch is the main reason for the CAPWAP tunnel to come up. DTLS is used for data encryption by CAPWAP. Because DTLS uses certificate-based authentication. DTLS handshake fails if the time between the two devices are different. Therefore, CapWeb tunnel will not come up. Okay, now let's move back to the question and find out what is the correct answer. Answer A. FortiSwitch cannot complete the DTLS handshake used in the CapWeb tunnel. Now you know this answer is correct. Answer B. FortiSwitch does not retain its time after reboot, which gets reset after each reboot. And also now you know this answer also correct. Answer C. FortiSwitch will not allow other FortiSwitch devices in the chain be discovered by FortiGate. This answer is wrong. Answer D. FortiSwitch will not be able to become an NTP server for downstream devices. This answer also incorrect. So the correct answers are answer A and B. Let's move to the third question. Which statement about using MAC, IP and protocol-based VLANs on FortiSwitch is true? Let's understand what is MAC, IP and protocol-based VLANs in FortiSwitch. You may assign ports to VLANs by configuring the native VLAN and allowed VLAN settings on the port. If you want to assign traffic to VLANs based on the source address and Ethernet protocol of the traffic, it is possible with MAC, IP and protocol-based VLANs in FortiSwitch. MAC, IP and protocol-based VLANs enable you to assign ingress traffic to VLANs based on the end devices, source MAC address, source IP address and Ethernet protocol. Then FortiSwitch overrides the VLAN settings on the port with the VLAN assigned to the end devices. Let's see the benefits of MAC, IP and protocol-based VLANs. One is that you can place different devices behind the same switch port in different VLANs. Another is mobility because end devices can be assigned to the same VLAN regardless of the switch port they are connected to. Another main benefit is MAC, IP and protocol-based VLANs can also be obtained with 802.1x authentication. As you know, 802.1x authentication is considered more scalable and secure. So, it is a better option. Therefore, MAC, IP and protocol-based VLANs are more often used as a solution for specific scenarios rather than as the main VLAN assignment method in the network. Okay, now let's go back to the question and find out the correct answer. Answer A. Endpoints are required to use the same FortiSwitch port to remain members of the VLAN. This answer is incorrect. Answer B. It provides benefits that can be obtained when using 802.1x authentication. As you learned earlier, this answer is correct. Answer C. FortiSwitch uses only the Ethernet type to assign traffic to VLANs. This answer is incorrect. Answer D. It is a scalable and secure solution in comparison to other layer 2 security measures. This answer also incorrect. So for this question, the correct answer is B. Further information related to MAC, IP, protocol-based VLAN, you can study more on FortiSwitch 7.2 study guide starting page number 376. Question number 4. What conditions does a FortiSwitch need to have to successfully configure the options shown in the exhibit above. Let's understand configuring split port on FortiSwitch. A split port lets you divide a 40 gig or 100 gig port into several ports that run at slower speeds. This is useful when you need to add more devices to your switch without adding more ports. For instance, you could split a 100 gig port into 4 25 gig ports or a 40 gig port into 4 10 gig ports. The table on this slide shows the supported split port modes for 40 gig and 100 gig FortiSwitch ports. Look at the command here. You can enable split port on supported ports by running the FortiSwitch OS CLI. Need to reboot the FortiSwitch to apply these changes. Because of the limitations on the maximum number of interfaces on some switches, the first step to configure split port is to select a port configuration layout for split port. In some Fortinet switch models, you need to select and disable some switch ports in order to enable split ports. As an example, on a FortiSwitch 548D model, you have two port configuration layout options. Option 1. Disable port 54 so you can enable split port on port 53 only. Option number 2. Disable port 41 to port 48 so you can enable split port on both port 53 and port 54. Let's go back to the question and find out what is the correct answer. Answer A. The FortiSwitch model is equipped with a maximum of 54 interfaces. This answer is incorrect. Answer B. The split port can be assigned to native VLAN. This answer is correct. After splitting, the port can be assigned to a native VLAN. Answer C. The port full speed prior the split was 100 gig QSFP plus. No, this answer is incorrect. Answer D. The CLI commands are enabling a split port into 4 10 Gbps interfaces. This answer is correct. So the correct answers are answer B and D. Further information related to split ports can study more on FortiSwitch 7.2 study guide, starting page number 252. Question number 5. In which two ways can you assign a FortiSwitch port to a VDOM using multi-tenancy setup? Let's understand what is multi-tenancy setup. FortiGate allows you to create VDOMs to separate your FortiGate into multiple logical devices. This logical segmentation on FortiGate is useful for MSSP and businesses with network deployments alike because it enables them to segment the network operation and its management. Assume you want to segment FortiSwitch devices across multiple VDOMs. One option is to have a Fortinet interface per VDOM. This approach requires you to deploy multiple FortiSwitch stacks, each of them with a separate physical connection to the VDOM FortiLink interface. A more cost-effective option is to use the FortiGate multi-tenancy feature for managed FortiSwitch stacks. This approach leverages dedicated VDOMs on the FortiGate to manage individual tenants. You can configure physical switch ports on the FortiSwitch to be leased to specific VDOMs, effectively creating isolated VLANs for each tenant. The tenant VDOMs then manage these leased ports directly, applying their own security policies and VLAN configurations. Multi-tenancy for managed FortiSwitch enables you to assign ports of your existing FortiSwitch stack to a different VDOM from the VDOM the FortiLink interface is configured on. You don't need to create additional FortiLink interfaces or make extra physical connections. You just have to assign a port to a VDOM, and then the port becomes available on the target VDOM for use. You can assign FortiSwitch port to a VDOM on the FortiGate CLI in two ways. The first way is from managed FortiSwitch directly, and the other way is from Virtual Port Pool (VPP). When using a VPP, you first indicate a group of ports that can be assigned to other VDOMs. VDOM-specific administrators can then pick one or more of those ports and use them for their respective VDOMs. Overall, FortiGate multi-tenancy setups with FortiSwitch provide efficiently managing and securing network environments with multiple tenants, offering a balance between resource sharing, isolation, and customization. Okay, let's go back to the question and find out what is the correct answer. Answer A. Assign a port to a VDOM directly on the managed FortiSwitch. As we learned, you know that this answer is correct. Answer B. Create a virtual port on the FortiSwitch CLI. Yes, this answer also correct. Answer C. Switch the FortiLink interface to the target VDOM. No, this answer is incorrect. Answer D. Remove the managed FortiSwitch and allocate ports directly on FortiSwitch. This answer also incorrect. The correct answers are answer A and B. Further information related to multi-tenancy, you can study more on FortiSwitch 7.2 study guide starting page number 299. Question number 6. How are the by VLAN redirect MAC address quarantine mode and the by redirect MAC address quarantine mode on FortiGate similar? Let's understand what is MAC address quarantine. MAC address quarantine means FortiSwitch and FortiGate work simultaneously to isolate a device. If device tries to communicate with any other host in the network, the communication will be blocked. To isolate a quarantined device, FortiSwitch forwards all its traffic to FortiGate. The traffic can come to FortiGate in three ways. The first way is FortiGate local. The destination is a FortiGate interface. The second way is intra-VLAN. The destination is a device in the same VLAN. Third way is inter-VLAN. The destination is a device in a different VLAN or network that is reached through FortiGate. For the FortiGate local traffic, the communication is permitted if FortiGate is configured to permit the connection. As an example, a quarantine device can ping a FortiGate interface if ping access is enabled on that interface. For the other traffic, the communication is blocked by FortiGate. There are two options to quarantine devices by MAC address: manually and automatically. Note that automatic quarantine requires a FortiAnalyzer device with a valid threat detection service license. Let's understand the difference between by VLAN redirect MAC address quarantine mode and by redirect MAC address quarantine mode. VLAN mode is the default mode. In this mode, FortiGate moves the quarantined MAC address to the quarantine VLAN. Assume that you are using default quarantine VLAN as your quarantine VLAN. The inter-VLAN traffic from the device is automatically blocked because the quarantine VLAN does not have any firewall policies configured. You may note that the device can still get an IP address through DHCP because the quarantine VLAN has the DHCP server enabled by default. The second mode is redirect mode. In this mode, FortiGate keeps the device in its current VLAN and adds the device MAC address to the quarantined device's firewall address group. To perform remediation, the device IP address will not change. In order to block the inter-VLAN traffic, you should configure a firewall policy to explicitly block the traffic from the quarantined device's address group. In by VLAN mode and in by redirect mode, the inter-VLAN traffic is automatically dropped by FortiGate because the destination MAC address of the traffic does not match the FortiGate interface. The destination MAC address of the traffic is the MAC address of the target device located in the same VLAN. Also note that communication between the quarantine devices and the FortiGate is allowed. You can use the CLI commands on this slide to change the MAC address quarantine mode on the FortiGate. Let's go back to the question and find out what is the correct answer. Answer A. Both modes block intra-VLAN traffic by FortiGate automatically. As we learned, you know that this answer is correct. Make sure that this is not inter-VLAN, it should be intra-VLAN. Answer B. Both modes move quarantine devices to the quarantine VLAN. This answer is incorrect. Answer C. Both modes require firewall policies to block inter-VLAN traffic. No, this answer is incorrect. Answer D. Both modes add quarantine device MAC addresses to the blocked firewall address group. This answer also incorrect. So after looking at all four answers given, we can consider that the answer A is correct. Further information related to MAC address quarantine, you can study more on FortiSwitch 7.2 study guide, starting page number 263. Question number 7. How does FortiSwitch perform actions on egress and ingress traffic using the access control list ACL? Let's understand what is ACL. ACL means Access Control List. It enables you to perform multiple actions on matching traffic that enters and leaves the switch. You can configure FortiSwitch to perform the following type of actions on traffic. First one, traffic processing. It includes count, drop, redirect or mirror frames. Second one, QoS, quality of service. It includes rate limit, set egress queue or remark COS, class of service and DHCP values on frames. Third one, VLAN, set outer VLAN tag on frames. To match traffic on ACLs, you configure classifiers. Classifiers enable you to match traffic using multiple criteria such as destination and source IP addresses, destination and source MAC addresses, COS and DHCP values, and VLAN ID. FortiSwitch checks ACL policies from top to bottom until it finds a match. There are up to 3 different stages you can configure ACLs depending on the FortiSwitch model. The stages are pre-lookup stage, ingress stage, egress stage. Pre-lookup is the first stage in the pipeline for the ingress traffic. It takes place before the switch performs layer 2 and layer 3 lookups, and it supports a reduced number of actions. If the action you need is supported on this stage, then in most cases, it is better to apply the action at this stage before the switch handles the traffic any further. Ingress. This is the second stage for ingress traffic. It supports a higher number of actions. Stage 3. Egress. Actions are applied on egress traffic only. And also, you may note that most of the FortiSwitch models support ACLs at the ingress stage. However, only some models support ACLs at the pre-lookup and egress stages. You can configure ACLs on FortiSwitch on the GUI and CLI. Now let's go back to the question and find out what is the correct answer. Answer A. ACL can be used only at the pre-lookup stage in the traffic processing pipeline. This answer is incorrect. Answer B. Classifiers enable matching traffic based only on the VLAN ID. This answer also incorrect. Answer C. FortiSwitch checks ACL policies only from top to bottom. As you may know, this answer is correct. Answer D. Only high-end FortiSwitch models support ACL. This answer also incorrect. So the correct answer for this question is answer C. FortiSwitch checks ACL policies only from top to bottom. Further information related to ACL, you can study more on FortiSwitch 7.2 study guide, starting page number 369. Okay guys, so we have come to the end of the lesson today. Hope all the questions we discussed are clear with you all. So thank you all for attending today's class at 591 Lab. We hope you found the material informative and very helpful. Remember, practice is critical to mastering any new skill. So, review the course content and keep practicing with 591 Lab help and support. If you have any concerns, questions, please don't hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Have a great day.